In this video, I'm going to talk about information from section 2.1 that talks about measuring growth for functions, and we're going to use examples from tables and graphs. So I'm going to jump into some slides that I have made, and we're going to go over some key terms and concepts from this section. So here I have the title slide. We've got this is the start of Unit 2, Section 2.1. In your book titled Measurements of Growth and How Fast is It Changing. Alright, so let's jump in and start looking at our first definitions. So we're going to look at independent versus dependent variables. So we say that an independent variable is a variable that's not affected by another variable. A dependent variable is affected by another variable. It's usually affected by the independent variable. So for example, we want the cost of attending a college or university from 1970 to 2010. Well, in this case, the independent variable is the time from 1970 to 2010. The dependent variable is the cost of attending the college or university, and that should kind of make sense, that the cost of attending depends on what year you attended college. So that's identifying independent versus dependent. So what about percent change? So percentage change tells us by what percent something has increased or decreased. And you'll see this example when you're shopping or hear in the news. So like on Amazon, they'll say that this is a 40% discount, which means that the price has decreased by 40%. And so that is the percentage change. But what if you're given the two values and you want to figure out, well, by what percent did they change? So let's look at this U.S. Census data. The U.S. population in 1790 and 1800 were approximately 3.9 million and 5.31 million respectively. So what was the percentage change in the U.S. population over this decade? So using this formula, we want to talk about the change in the function. So the function's really just another way of saying the dependent variable. In this case, the dependent variable is the population of the U.S. So I want to figure out how much did the population of the U.S. change. So I've got this population and this population. So what was the change in population? Then we would do 5.31 million minus 3.93 million divided by, and then it says from the formula, the previous function value. So what was the previous population? It was 3.93 million. And then we want to multiply that by 100%. So if I do all that calculation, I get 35.11%. So we say that the population of the U.S. over that decade increased by 35.11%. So let's look at average growth rate. So this is another concept in your textbook, and it is a little different from percentage change. So the average growth rate of a function is the change in the function divided by the change in the independent variable. And in a lot of textbooks, this is really the same thing as slope. So if you remember from previous courses talking about slope, that is exactly what this is right here. This is really just talking about the slope of a function. All right, so let's talk about our average growth rate example. So we've got this table that's talking about the expenditures for colleges and universities in millions of dollars. So this is how much total in the U.S. universities and colleges expended during that given year in millions. So we want to use this table to calculate the average growth rate from 1970 to 1980. So again, we're looking for the change in the function divided by the change in the independent variable. In this case, the expenditures is the function. And the years is going to be the independent variable. So over this time interval, 1970 to 1980, the change in the function is going to be the change in expenditure. So that's going to be 56,914, and again this is in millions of dollars, minus 21,043 million dollars, divided by the change in the independent variable, which is the time. So the change in time was 10 years. So if I do this calculation real quick, I get this to be 3,587.1. Again, this is in millions of dollars. So on average, over that decade, it was increasing by 3,587.1 million, which re-expressed is about $3.5 trillion in this particular example. All right, so let's keep going. Let's talk about interpolation. This is a next concept, and interpolation actually uses the average growth rate to find a value. So for example, what if we had that same table from the previous slide, but we wanted to estimate how much colleges and universities expenditures was in 1975. So how can I do that? Well, I know from the previous slide that so just as a note, from 1970 to 1980, it was increasing by $3,587.1 million each year. So starting in 1970 going to 1975, that's a 5-year time increase. So I could say, okay, well, if I wanted to estimate 1975, so we'll just start there with the first one. In 1970, we had 21,043 million. And each year it's increasing by that 3,587.1. So it's increasing, so I'm going to add that 3,587.1 million. And I'm going to do that for 5 years. So I multiply that by 5. So if I do 21,043 plus 3,587.1 times 5, that gives me 38,978.5. So inside that box, I should have 38,978.5. All right. So what about that second missing piece in 1993? Well, again, I need to figure out what was the average growth rate between these 2 years. So if I do that, so now we need to look from 1990 to 2000. That's going to be a little different. So we're going to do 236,784 minus 134,656 divided by 10. That's going to give me an average growth rate of 10,212.8 million. So if I wanted 1993, I'm going to start at 1990. And I'm going to add the average growth rate over that decade. And I'm only going to do it this time for 3 years because there's only a 3-year gap there. So if I do that, I get that to equal $165,294.4 million. All right, and so that number would go inside that other box, but the box is getting a little small. All right, so let's keep going. Let's look at, so those were in interpolations. They were inside, but now we want to extrapolate. So finding an unknown value that's outside my data point. So we've got all this information, same table, but now we want to estimate for 2018. Okay, so in order to do that, I want to use the closest values I have to 2018. So from 2000 to 2010. So again, I need to calculate the average growth rate from 2000 to 2010. Okay, so that would be so 461 minus 2. That gives me 22,421.6 million. I really should have mentioned that each one of these is in $1 million per year. So I should scroll up here and also say that this is $1 million per year. Per year. Because the growth is happening each year in those cases. All right, so how do we get 2018? Well, if I start in 2010, and I had 461,000 million dollars, and I'm adding approximately $22,421.6 million each year. I'm going to do that for 18 years because there's an 18-year gap there. So if I do that, I end up with 864,588.8 million. So then that would be how much that we would expect the expenditures to have been in that time frame. So I need to go back up here and also make an amendment to something I said. It was about, I guess, right here, that this is actually 3,587,000,000 rather than 3 trillion. Because this is inching close to 1 trillion. Because we're getting close to 1 million millions. Which that would be a trillion. So this is getting really close to $1 trillion spent here. All right. So I hope that's helpful. And if you have any questions, please feel free to contact me. My information's on the syllabus. I look forward to hearing from you soon.